So the quadratic formula is when we take those trinomials, the ones that we've been doing, they take that form ax squared plus bx plus c equals 0, and then we have what's called the quadratic formula to solve them, so we don't actually have to factor them. As fun as that is, you can, if you wanted to, on all the previous ones that we've solved, you could have just used the quadratic formula, but if it's not factorable, then we almost have to use the quadratic formula. So if you were to take this formula right here, and if you were a math nerd of some degree, you would sit down and be like, you know what, I want to solve for x on this sucker right here. And as it turns out, you would, much to the chagrin of many students that follow after. And you probably wouldn't want to share that information with family or friends because you wouldn't have any anymore. But in any case, what we have here is the standard form for a, I guess, trinomial or quadratic. And x, if this equals 0, the x value that makes that 0, you get 2 of them. That's why this is plus or minus, but it follows this formula. Now this is going to sound weird.
So that's a quadratic.
So I memorized this from a song. Not like a song someone put this to music. It was just part of a song, and I remember hearing it in high school. So this goes back to the 90s. It's the band is called, if you want to look them up, it's called Skankin' Pickle.
The skanking the pickle?
The Skankin' Pickle. And the name of the song that has this formula in it, it's called Don't Judge a Man by the Hair on His Butt.
I'm sorry, what?
That's the name of the
What
song.
is the name of the song? Don't check everyone. Yes, that's
You can listen to that song if you want, or you can just look at it and memorize it, because it's fun to do that too. So now you'll keep in mind if this square root, if you evaluate the inside of that square root, that radicand, and it comes out negative, then you're going to have a complex number or imaginary number, because a negative square root comes out as an I. Now if that square root is simplifiable, then you should. If it's not, then keep it as is. Generally speaking, they write this as 2 separate answers. If it looks, some of these are going to look poor. Sometimes this just evaluates nice and you get like 5 or 5i, for example. But sometimes the answer kind of looks nasty. Math nerds though would say that's not that bad. But this formula, negative b plus or minus, and again that's why it's 2 equations. One of them adds and the other subtracts. That happens from when you square both sides, right? We know that gives us 2 answers, 1 positive, 1 negative, and you got the square root of b squared minus 4ac all over 2a. So keep this in mind. If you have minus b right there, you have negative b, which makes that b positive. Now, of course, b squared, it doesn't matter if that's positive or negative. That's always going to come out as positive. But minus 4ac, if 4 times a times c is bigger than b squared, then you end up with a negative inside the square root, which makes it an imaginary number. That may not make a lot of sense right now, but hopefully we'll get enough experience doing this where it will, hopefully, maybe. So another thing about this is, with this complex number specifically, is if you're using a calculator to type this stuff in, then you're going to get like a domain error. If you're using the same calculator I am, TI-30XS multi-view, which is a good one. So if we get something like that, then we know that we have to do some of this by hand. What that means if you end up with a domain error is that this is a negative inside of the square root. Later on, we're going to learn that that's called the discriminant, but we don't care about that right now. All we need to know is if we get a negative right here, just pull the I out, and then you just kind of plug that into the calculator. The other thing you're going to want to remember is that this equals 0, right? That's important for our quadratic equations, and equals 0. If it does not equal 0, you're going to have to force it to equal 0 using principles of equality, and we'll see some examples like that too. Okay, so for this one, I'm going to use this quadratic formula, and I'm going to do it twice just so you can see what is happening right here. Now, if you really want to see how we get this formula, I've made a video on it. You can imagine how popular that is. But we got negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I'm just kind of setting this up. And like I said, I'm going to do this twice. So the first one I'm going to do, maybe I should do addition, but I'm going to do subtraction first just so I can copy this over. Okay, so let's take that, move it over here. And the first one I'll do subtraction, the second one I'll do addition. And as much as you want me to do this by hand, I'm going to use a calculator. So let's see what happens on this. So my b right here, b is showing that's the middle coefficient of negative 21. And so I put in, it's a negative 21. That'll make that positive, of course. And then it's also a b squared, so that's a negative 21 squared there. My a here is showing as negative 4, so that'd be 4 times that negative 4, the a. And then also down here, this 2a, that a right there should be negative 4. So I've got my a, my b, oh crap. All I need now is the c, right? Well, the c is this negative 5. And remember, the operation to its left is the sign, and that goes inside the square root. That's a negative 5 right there. Okay, so again, all I'm going to do is plug this into the calculator. Let's see what it gives me. Because I didn't use my n over d button, I now have in my numerator 2. I got 2, and then the denominator, I know 2 times negative 4 is negative 8. So this should come out as a negative 1/4 right there. That should be one of my x values. Now I can make sure. So that negative 1/4. Now, as it turns out, I can go back to the original because I do want to check, right? And I'll say, look, I'm just going to plug this negative 1/4 into this equation. So I got negative 4 parentheses negative 1/4 close parentheses minus 21 times negative 1/4 minus 5. Enter. I replaced my x's here with negative 1/4, and when I did, I got a true statement because on the left side I got 0, and as it turns out, 0 equals 0.
Why do I have 1/5?
All right, now everything else is going to work the same on this next one, right? So the b value is still negative 21. Okay, so I got my b's in there. Let's put the a in there. So it's a negative 4, and even this a down here is going to be negative 4. And then, yeah, we know the c value is negative 5. Okay, so I'm going to type this in again. This time I'll try to do it right. So I'm going to use n over d, and then I got negative 21. So that's just positive 21. You can put negative if you want. I think the calculator knows. But plus square root and negative 21. This negative 21 that I'm putting in right here, make sure you use this parentheses right here. Otherwise, it'll think you want the negative of 21 squared. So you got to have parentheses around there. Negative 21 squared minus 4 times negative 4 times negative 5. Then I go to the denominator, 2 times negative 4. Enter. Oh, I typed it in wrong again, but let's try to do this right. There we go. In the calculator, it simplified it already for me. Thank you, calculator. I got negative 5. Now, if this is right, so I'm going to store negative 5 in for x, and I'm just going to type in the equation. So negative 4x squared minus 21x minus 5, and it said this side right here equals 0 again. So I now know that negative 5 also is a solution. So we have 2 solutions for this one. And I think I've mentioned this before. When we have a degree 2 polynomial like this, we should expect to see 2 answers. Sometimes they're imaginary, sometimes they're real, like these 2 are, even though they're negative. But if you see a power of 2 as the degree of the polynomial, then you can expect there to be 2 answers. So again, I'm just setting this up. I got my minus there. Of course, it happens twice. So I'm going to take this one and move it over here, and I'll change, instead of the minus, it'll be plus right there. So there we go. Now, we see here that the a value is 9. I'll start with a. I tend to start with b just because it's kind of the first term or value in the quadratic formula, but a is fine as well. It's 9, positive, which is good. Oh, and I put the plus there. Yeah, it should be minus, right? I don't know why I put plus, but it is minus. All right, so there's that one, and yeah, those should be minuses. And then we got an a on the bottom as well, right? So I can do it over here as well. Let's see if I can do it better. 9, that's okay. So that's my a's. I got a b value here that's negative 24. It's kind of big, so this would be negative 24 there. Negative 24 here. And again, when you put this part in the calculator, make sure that you use parentheses around that negative. Otherwise, it's going to think you want the wrong thing, which we don't want. And then the c value here is the constant, just 10 right there. So that's just inside that square root. Well, now that we have this written out, let's see what happens when we put this in the calculator. Now, just before we continue here, I'm kind of assuming that this is going to give us some kind of, well, I guess 24 squared is kind of big. Let's see what happens. So I pushed enter.
Can we do decimals here?
So on my calculator, this is what it's showing me. It says it's the negative square root of 6 plus 4 over 3. I'm going to rearrange this so it kind of looks like it was evaluated or simplified. I'm going to make it 4 minus the square root of 6. So what happened is...
What did your calculator give you?
So, maybe I should evaluate this. Let's take a look. Okay. So I'm just going to work through this. I know we just found the answer, but we're going to see it again. The denominator, hey, that's not too bad. 2 times 9, 18. I can do that in my head, in fact. Negative 24 would be 24 minus. And then in the square root, I'd have the negative 24 squared, which would have been 576. And then minus 4 times 9 times 10 should have been 360 right there. So 576 minus 360 gives me 216. So that would have been 24 minus the square root of 216 all over 18. And then this, the 216. So the square root of 216, I'm still using the calculator, by the way, but that's 24 then minus 6 times the square root of 6 all over 18. But what we see here is that 24, 6, and 18, because we could separate this into two separate fractions. 24 over 18 minus 6 square root of 6 over 18. 24 and 18 are divisible by 6, so I would make that 4/3. And then 6 and 18 are divisible by 6 as well. That'd be 1 and 3. So we have the same denominator, and with a little bit more space, we can write this again as it would have been 4/3 minus the square root of 6 over 3. But we can, like I had shown before, this could be combined into one fraction as 4 minus the square root of 6 all over 3. Now that's the same exact answer we had before. I just did the work by hand. What I have here at the end is the same thing that we've done before. Again, if you put this into the calculator and you got this, or the other way that I had it, right? Negative 6 plus 4 over 3, that's fine. I don't really need to see any of this work. You probably want to show this, though, because you need some work. Now, some students like to show it like this as well. This one's okay, too. It's exactly the same thing as what I have written here. In fact, I wouldn't even say this one is more simplified, but some students like to show it like this, and that should be worth full credit, too. Now, as fun as that was only one of them. We've now got to do the other one, right? So I got my n over d, negative 24, but plus now the square root of negative 24 squared in parentheses minus 4 times 9 times 10 all over 2 times 9. Enter. And so again, this one, it's saying, well, you got an answer, and it's showing me the square root of 6. See if I can do this better. It's showing me the square root of 6 plus 4 all over 3, and that would be fine. But again, I'm just going to relate this. I'm going to write it kind of the same way that the quadratic formula is written. So I'm going to write the constant first, the 4, and then that would be positive square root of 6 all over 3. So that means that over here, instead of this being minus, right, it ends up being plus, which is why the quadratic formula also shows as just plus or minus. Because generally speaking, it just is the minus and then the plus. They're just separated. And this is what we want. We want to see the root. This is the exact answer as a fraction. We don't really want to see those decimals on these. So the way this is written, it is, I would say, I would consider it in my mind, it's symmetric. I don't know if that really makes sense, though. But if you had just used the quadratic formula, they would have shown it like this. 4 plus or minus the square root of 6 all over 3. And this is two answers in one.
Right.
It's just do you want to write two answers? Do you want to write one answer twice in the same problem? It means the same thing, though. So let's go through this one. So again, I got my a value that's 4, and that's nice because it's that'd be 4 times 4 in the numerator, and in the denominator would have 2 times 4. So, but I can put it in both of the equations, right? And then my b value is showing as -3. It being negative is hopefully not a problem there, because we can just type it into the calculator with some parentheses, and it's going to be in both equations. The final value here, it's showing as +12. It needs to equal 0. Okay, so your quadratic equations have to equal 0. So on this one, you'd have to make it 0 by subtracting 6 from both sides. I suppose I should have done that first, but that does make that equal 0, but 12 minus 6 would be 6. That's my actual C value right here, not 12. So be careful on this one. If it doesn't equal 0, you need to make it equal 0. And now my C value is 6. I really don't need that equal 0, but 6. Okay, so 4 times A times C. Now it's 4 times 4 times 6. Well, as some of you found out, when you type this into the calculator, you get a domain error. So when you put in the calculator, either one of these, you're going to get a domain error. So what does this mean? The domain, let me see if I can, there we go. The domain error means that, and this is kind of what I talked about on the introduction slide, is this is a complex number. Imaginary. So it's an imaginary number.
Was that divided?
Now, yeah, so why is it an imaginary number? It's because inside this square root, you're going to get a negative.
-87.
Yes,
Which is a 3
negative
times
87. That's correct.
9.
All right, now so this means if you get a domain error on your calculator, it's outside the domain. It's not real, which means it has to be imaginary. So we do have to work this one a little bit by hand, right? Like in this fraction, I already know that my denominator 2 times 4 is 8, and that's nice. Also, -3 is just really +3, and that's fine. I got my minus, and I got my square root going on here. So inside my square root, though, I've got a 9. And this would be minus 4 times 4 times 6.
96.
Thank you, 96. So I'll make this one green, I guess. Okay, now from here, let's see if I can, I probably should get some more space. Let's simplify this, the square root specifically. So this is 3 minus the square root of something all over 8. And 9 minus 96 would be -87. Okay, so you see, now we have the square root of a negative, which is no good. I can take that negative out by just making it an I value on the outside right there. So I guess I'm kind of skipping a little bit here, but we've seen that before. You can yank out the negative as an I. That's telling us that this whole thing is imaginary. It doesn't exist in reality. It's in someone's imagination, I suppose. Mathematically, it does exist, though, which is kind of weird. But I don't see that I can simplify this. The square root of 87, I can't find any factors of 87. In fact, it could be prime, but I don't know of any factors of 87 that are perfect squares. So this right here it's actually simplified.
That's it?
This one is. Yeah, so that's a good point. In the calculator, here's what I would do, is once I get a domain error, I would evaluate the inside of the square root, right? So once I get -87, I yank out the I, know it's there, and then I can type 3 minus the square root of 87 over 8, and it will simplify that for me. All right, now that's one of the answers. Really, the other answer should be plus, but let's just double check here, okay? So, again, I would expect another fraction here, but this time it's plus and the square root. Again, 2 times 4 is 8, and that's fun. The -3 makes that positive. But now I've got a 9 minus, it's still 9 minus 96. So you can see it ends up being the same thing, just with a plus sign now. So you got a 3 and an 8, and then plus. So this would have been the square root of -87 again, but I don't want the negative there, so I yank that out as an imaginary value. So this is it. Now, again, you should check. Again, if you wanted to just put this in the calculator, 3 plus, use the N over D button, 3 plus the square root of 87 all over 8. Notice how I skipped the I in the calculator because it doesn't know I. So if I put that in the calculator, it will then simplify that much for me if I wasn't sure that this could be simplified. But you can type that in. Again, I know 87, it can't be factored. 3 and 8 can't be simplified either. So that's a pretty good sign that it can't be simplified any further anyways. But we get these two answers. Again, the actual quadratic formula would have just put a plus minus between these, which you can see. Same exact values, but this operation changes from minus to plus. Okay, so we have this set up. Now the problem with this one right now is that it's not in quadratic form, quadratic formula form. Quadratic form, there we go. So I'm going to force it to be. And there's two ways to do it. Some students like to add 20t to both sides, 20t squares to both sides, make this equal 0. I'm kind of the type that likes to just subtract 26t and then subtract a from both sides. And then it doesn't matter which one you do, you're going to get the same answer, by the way. So I'm going to, fair enough, let's do that. So for this one, let's take that negative 20t squared and add it to both sides. Now I'm kind of trying to keep that offset from the 26t because it's not a like term that I can combine with it. But what does happen here, and this is what we wanted, was this to be 0 equals now 20t squared. Then we had a positive 26t and then a positive 8. So I'm using these values. I have an a value that's 20. I've got a b value that's 26, and then a c value that's 8. So for my quadratic formula, I can start entering these in, right? And the b value, I guess, for the first time tonight, I think, positive 26. I got a 26 squared. I don't really need parentheses there. This one as well. You can have the parentheses. You don't really need them when it's positive like that. And then we got an a value that's 20, so 4 times 20, and then 2 times 20 as well. And then over here, 4 times 20 and 2 times 20 also. So C is 8, and that's just inside that square root there. So I'll multiply that by 8 in both of them. All right, now we go to the calculator, and let's type this in. So I'm using n over d, negative 26 minus the square root of 26 squared minus 4 times 20 times 8 all over 2 times 20, enter. And this first one with the minus gives me negative 4/5. There, now that should work. You can plug this back into this original equation and see that it works. Let's do the other one. Now, to do the other one, I just go up to my original equation. I push enter. And if I could just go back and then instead of have minus, I'm just going to change that minus to plus and then push enter. It just saves me some typing in the calculator, but this gives me a negative 1/2. Now again, since all of this was done using a calculator, I highly recommend that you type these in to the t values to make sure they do work. They do, because I already did it earlier, but make sure you do it, especially if it's on an exam and you're strictly using a calculator to evaluate these. It's okay to make sure you plug them back in to make sure it gives you a true statement. For those of you interested in how we go from this to this, that's what I'm going to do right here. So the rest of this I don't really care about. Let's just focus on this part. And I also don't care that a could not be 0, so I don't really care about that. But again, how do we get from here to here? Now the first thing for me that I want to do, that I would like to do, is since I'm looking to complete the square right now, which will allow me to kind of isolate the x's, right, is I want to get rid of that c, meaning I want to zero it out. So I'm going to use a principle of equality by subtracting c from both sides. So that will zero that out as planned, and now I'm left with this ax squared plus bx, but now it equals a negative c instead of 0, okay? And from here, yeah, let's give myself a little space. What I want to do now is I want to complete this square so that I can look at this as a binomial squared, right? What I would like to see here is something squared, some kind of binomial squared equals something else. Now I think some of you guys remember that for this to happen, I don't want a coefficient of x squared. I don't want this a there, so I gotta take that out. All right, so I'm gonna factor that out. So let's take an a out of that term, but if I do that, it will affect the other term as well. So I am left with an x squared there, but my plus b is now, it would have been b over a, because there wasn't an a there, so it's like you'd have an a over an a, but you pulled out the numerator a. Now if that doesn't make sense, it's okay. but just know that if I yank an a out from, I can't just do it to one. I got to do the both terms. And since there wasn't an a right here, again, think about this. Like if you were to redistribute the a back in, this a divided by this a would become a phantom one. You'd just be left with bx, which is what we want. Now to make this just a little bit easier, I'm going to divide both sides by a. And what does this do for me? It just makes that a phantom one, right? So now I'm left with an x squared plus b over a times x, and this equals now negative c over a. Like this. So now that I have that, I can complete my square here. So to do that though, right, you take your b over a, and you'd have to divide that by 2. Now dividing that by 2 makes this really just b over 2a, which should look familiar. And remember, from this, you square that, okay? So this would show, though, if we were to square it, as b squared over 4a squared, using some exponent rules. For the left side, though, I'm just going to show it as plus b over 2a squared, because remember, this is all part of completing the square in order to make this x, and then we would have that plus b over 2a. And that would complete the square. But remember, if I were to add this here on this left side, I put that in there. So as a principle of equality, if I do it to one side, I need to do it to the other side. So I'd have to put plus, again, I'm going to evaluate that as b squared over 4a squared. And that just kind of drops down here. Now at this point, right, we're kind of looking to square root both sides. The problem is that if I square root this side, it's going to jack things up with all this adding of this fraction business. So what I'm going to do then is I'm going to take these two, I'm going to make it one fraction by forcing the denominators to match. So that means I'm not really concerned right now. I'm not concerned with the left side of this equation. I'm worried about the right side. So to make these denominators match, first off, the green part, the negative c over a, I would have to multiply by 4. And then I would need another a there in the denominator. That makes 4a squared, but if I do it to the bottom, I got to do it to the top. Now what this does for us is it now gives me a new fraction of, I'll show it as negative 4ac, that should sound familiar, all over 4a squared, and then this is still plus the b squared over 4a squared. And now that the denominators match, well, we can show this as one fraction with a common denominator of 4a squared. So how many did we have? Well, you had a negative 4ac of them, and then you had also a positive b squared of them. In fact, if we were to make this very applicable, some more space, then I would switch the order there, and it still is over 4a squared. But now I would show this as b squared minus 4ac. And then I can worry about the left side now. Because at this point, to solve for x, what I would need to do is square root both sides of the equation, right? And that gets rid of our x squared. But by doing that, it also gives us the positive and negative solutions there. So what am I left with? Well, I've got my x plus b over 2a, and the numerator and denominator there with this square root, and again, plus or minus tells us there's going to be two solutions. But I'm going to separate that into two separate square roots. Okay, so I got the square root of what would be b squared minus 4ac, and again, that should look pretty familiar. And this is all over the square root also of 4a squared. So why would I do that? It's because 4 and a squared are both perfect squares, that then I can square root. In other words, the denominator of this fraction then, the square root of 4 is 2, and the square root of a squared is just a. Everything else remains. And from this point, all I need is a principle of equality to kind of finish this off. Now, I'm going to show this a little different, then I'm going to switch the order. But to solve for x, all I got to do is get rid of this b over 2a, right? So I'd subtract b over 2a from both sides. So I'm showing it as minus b over 2a over here. And this does solve for x because that zeroes out this stuff. Now, again, I'm going to switch the order. I'm going to show it as a negative b over 2a, and that's on purpose. And then would say plus or minus the rest of that. And then we can see that the denominators match. So again, we can change that back into one full fraction, right? Where the denominator is just 2a. But what would we be left with? Well, you got a negative b. This would be plus or minus that square root, which was showing as b squared, and then a negative 4ac, which is the quadratic formula down here, right? There it is. So this is how you change ax squared plus bx plus c equals 0 into the quadratic form, which really just gives you the ability to solve for x with a formula. This, by the way, is another form of manipulating equations. It's the formula section, which takes us back to 5.8. It's just now we have more stuff to work with, not just principles of equality, not just like square rooting or squaring both sides. Now we also included some completing the square, and yeah, there was some square root stuff in there, and some forcing denominators to be the same. But this is how you change our original quadratic form into the quadratic formula, which is how we solve for x.